This example reads, the percentage of people not covered by health insurance in 2003 was 15.6%. A congressional committee has been charged with conducting a sample survey to obtain more current information. What sample size would you recommend if the committee's goal is to estimate the current proportion of individuals without health insurance with a margin of error of 0.03 or 3%? Assume a 90% confidence level. So for this question, I can see that they want the sample size. What sample size? That's the question. So what's the sample size? And that's what we want to find. And not only is it a sample size, but it's the sample size of a proportion. So I know right there that the formula I'm going to use for the sample size for proportion is going to be n is equal to z of alpha over 2 squared. This formula you may see in different forms, but it always comes out to the same answer. It may look slightly different, but I assure you it's going to be the same. 1 minus p, and the whole lot is going to be divided by the margin of error squared. So that's what we need to find out. We're given most of that information. So, well, 90% confidence interval, that means alpha is 10%. So I'm going to need that so I can work out z of alpha over 2. And we know that the proportion was 15.6%, so I'm going to use the proportion that I had, which is 0. Even though it's an old figure, I'm still going to use that. Don't have anything else. Always use the best information available to me. And we are told that the margin of error is 3%. So I can just put the margin of error equals 0.03. So I know what this guy is, same as this. I know what the margin of error is, and I can work this out because I know what alpha is. So let's find that. So what is z of alpha over 2 going to be? Z of alpha over 2 is going to be z of 5%. And for z of 5%, I'm going to be using norm.s.inverse. So let's do norm.s.inverse. Oh, what number should we be using here? So, well, normal distribution, and z of 5% is this point here, where this area in here is 5%. Just means the area in the tip or the tail is 5%. Now Excel wants the area to the left of that point. The area to the left of that point is 95%. So I'm going to put 0.95 in there to get the answer. So let me pop over to Excel. So let's scroll down to somewhere new. So we're going to use equals, let's see, norm.s.inverse of 0.95, and that's going to give me my critical value, my z of alpha over 2 value of 1.64485,363. So let's say 1.645. So let's go over to here. So I can just plug everything into here, into this formula here to work it out. So it's going to be equal to, the sample size is going to be equal to 1.645 squared. And I'm going to multiply that by p, and we know p is 0.156, that's the p, times 1 minus p, times 1 minus 0.156, and then we want the whole thing divided by the margin of error, which is 0.03, and we want that squared. So we can go over into Excel and do that over there. You can do it on your calculator. I wouldn't recommend that you do it on your calculator. So let's jump over to Excel and see what we can do now. So we already have the first part, which is the z of alpha part. We already know what z of alpha is. That's good. And what else do we have? We know that the p value is going to be 0.156, and we know that the margin of error is going to be equal to 0.03. So we can do it in one fell swoop, or you can do it in parts. If we do it in one fell swoop, it's going to be equal to this value, z of alpha over 2 squared. So I'm going to press shift and 6 and put the 2. So that's going to be 1.644 squared. And then I want to multiply that by p. So p is that. And then I want to multiply that by 1 minus p, close parentheses. And then I want to divide out the whole lot by the margin of error squared, which is going to be 0.03 squared. So it's going to be shift 6 squared. And let's see what that gives us. That gives us a large answer of 395.8. So let's go back over to put that in. And so what do we have here? So this just equals 395.8. Now we can't get 395.8 people, so we have to round it. We always round up. So our final answer is that the sample size is actually going to be 396 people. Always round up. It doesn't matter if that's 0.1 or 0.2. You don't round to the nearest, you always round up.